Well, hey there, kiddos. Today we're going to talk about something called domain and range, which involves the graphs of functions, which is a word you haven't learned yet, but it's the graph of equations, and the domain and the range helps us determine where the graph begins and ends, depending on whether we're looking left to right or up and down. And so we're going to do some definitions first. I'm going to put this slide up here. It's got 5 definitions on it, and I'm going to walk through these with you really quickly, but you're probably going to need to pause this video so you can write down the definitions so that you will have what they are, because they especially domain, range, continuous graph, and discrete graph, those are very important. So the first definition is ordered pair. This one you should know. An ordered pair is a pair of numbers always in the form x, y that can be used to locate a point on a coordinate plane. They're the points you use when you're plotting points on a graph. The x comes first, the y comes second. Domain is the set of all possible input values of a relation or function. In our case, we're going to call that equation, or it's the x values. So domain is all of the x values on a graph. The important part that you need to remember here is that domain is the x values. That's the important part. Range is the set of output values, or all of the y values. So that's the part you need to remember. Domain x, range is y. A continuous graph. A continuous graph is a graph that is made up of connected lines or curves. So everything is connected. It all flows nice and smooth in a nice easy line, and everything is connected, doesn't have any gaps. A discrete graph is a graph that is made up of unconnected points and it has gaps in it. So let's see some examples. Please make sure you get all 5 of these definitions written down. So if you need to pause now and do that, please do so. So we're going to do domain and range of some graphs, of some functions, and we're going to just first talk about whether or not it's a discrete graph or a continuous graph, and then the things that we need to know in order to do this. So here's your first graph. You can either sketch it, or up on my website and on Edline, I have put these notes so you can go print them so you can have the pretty little graphs all so that you can use them and not have to sketch these graphs. Or you can do like Aubrey did last year, and you can just print screen everything and print it out. But the actual notes are on Edline. They are on my website. You can go get them and print them. So this graph right here, first of all, it is a discrete graph because this graph is made up of only points. They are not connected, and so that makes it discrete. So this is a discrete graph because the points are not connected. It has gaps. It's got holes in it. The first thing it asks us to do is list the ordered pair. So we're going to start on the left and work our way over to the right and list the ordered pair. So this is our first ordered pair right here, and it looks to me like that is at negative 1, 2, 3, 4, up 2. The next ordered pair is this one right here, and it looks like it's at negative 2, negative 1. And then this ordered pair is going to be at 0, negative 2. This next ordered pair is going to be symmetrical with this one, so it's going to be at 2, negative 1, and then the last ordered pair is going to be at 4, positive 2. Now, when it's a discrete graph, the domain is really simple. This is the reason why we write the ordered pairs. Domain is all of the x values, and so the domain for this is going to be very simple. I'm just going to list all of the x values, and the only things I will not write are things that repeat themselves, so that's very important. So if I look at my ordered pairs, all I'm going to do is write down the x values. So I have negative 4, negative 2, 0, 2, and 4. And when you list them, you always make sure you list them in order from least to greatest. And so we're going to write them all down. Negative 4, negative 2, 0, 2, and 4. That's my domain. Those are all of the x values that are on this graph. Since it is not continuous, I can just list them out. My range, and I'm going to change color here to make it easier to see. My range, oh, and by the way, it always goes inside these squiggly little brackets. If you have trouble drawing the squiggly bracket, okay, you got a couple options. You can draw me a squiggly line, or you can do an S with an S on top of it, sort of makes a squiggly little bracket, or, you know, just don't do this or this. Don't do those. It's got to be a squiggly bracket, so make it squiggly. Make it, you know, kind of funny looking. But you need to make sure it has a squiggly bracket on the outside of it. That's how we make note that it's going to be a set of numbers. Now our range is going to be all of the y values. So I'm going to go through here and just list the y values. And again, they have to be in order least to greatest. So I've got 2, -1, -2, -1, and 2. Well, the -1s repeat and the 2's repeat. So I'm only going to write them once because once it's there, there's no reason to write it again. But I have to start with the smallest one. So the smallest y value happens to be that -2. My next smallest y value is -1. And once I have written it once, I have used it. There's no reason to write it a second time. We do not want to be redundant and repeat ourselves. And then the next one is the +2. So my range is smaller than my domain, but that's just because my range had values that repeated. But so my domain is those numbers, my range is those numbers. So what that tells somebody looking is that I have a graph that goes from -4 to +4, and it includes these 5 numbers. And then my range, and that's the left to right. Then up and down it goes from -2 to +2 and only includes these 3 numbers. So the next example, this is a continuous graph because if you will notice, this graph is connected. There are no gaps, there are no holes, it doesn't have anything happening. So we have this pretty little graph. Now we are not going to write the ordered pairs for this because it is continuous. We only write ordered pairs when we are doing a discrete graph. Let's review open circle and closed circle. Closed circle, if you will remember from inequalities, means that this number is included as part of the answer. It means I actually have a point here. This open circle means I have a hole in my graph. This number is not included. And so it means my graph goes all the way up to that point but doesn't really get to there because there's a hole here. And so it goes all the way up to that point and then just falls in because there's a hole. So domain, here is how domain works. Whenever we do domain, I'm going to pick a color here so that it will actually show up on my graph. Whenever you do domain, domain always goes from left to right. So I'm going to mark the left and the right-hand side of my graph with these pretty little lines. It goes from here to here, and since there are no gaps or holes in the middle of my graph anywhere, it doesn't stop. It goes from here to here. When I write my domain, I always start with the point all the way furthest to the left, which happens to be this one right here. And if I count that x value, it happens to be at -1, 2, 3, 4. So my domain starts, and we're going to list it again as a set of numbers with the squiggly bracket. It starts at -4. Then it goes all the way along here and over to here and ends right here at this x value, which happens to be at 1, 2, 3, 4, 5, 6, 7, 8. And the reason why I put this here is because look, it ends right there. I don't have to look at it. And so it's going to end at 8. So it starts at -4, ends at +8, and my x, all of my values for x are going to be in between those two numbers. And so we're going to write this like we would a compound inequality. All of the numbers from -4 to +8 are included. -4 is definitely included because it has a closed circle. 8 is not because it has an open circle or a hole. So at 8, I just put my less than symbol because 8 cannot be considered part of the domain because of that hole. The -4, however, can be considered part of the domain, and so it becomes the or equal to symbol. Now when you're writing domain and range, as long as you go least to greatest, you will always use less than symbols because x is every number less than 8 because it's at 8 and smaller, and it's every number greater than -4 because it starts at -4 and goes to the right. So we include it this way. This says x is in between the two. And as long as you go least to greatest, your symbols will always be less than symbols. Now there is another way to write domain and range. This is set notation. The other way we're going to write it is going to be called interval notation. Interval notation is easier, but you need to understand both. Since my -4 is included, when I write interval notation, I put a square bracket around it to show that -4 can be part of my domain, that there's really a point there. My 8, since there is a hole at that 8, that open circle, has to have a parentheses around it because what that means is that there 8 really cannot be there because there's a hole, and so I have to put the parentheses to show it's not included. This is called set notation. This is interval notation. You need to know both, but so that's what they are. So now let's do range. And I'm going to do the same thing, except I'm going to move my lines so that you can see what's going on. And I'm going to go and I'm going to put lines on again. This time, let's use these. Let's do this. We'll use that green one, okay? So now range happens to go, you can ignore that, I didn't mean for it to place. Range goes from bottom to top because it is always going to be the y values, and y's go vertical up and down. And so when I do my range, I'm going to draw a line down here across the bottom of my graph, and then I'm going to do the same thing and put a line across the top of my graph. Edges of paper, post-it notes, note cards, all work really, really good for this. But so here's what I'm going to do. I know I have to go from the bottom to the top. So down here at the bottom, I have 2 points. I've got a point here, and I have this open circle, this hole right here. They both happen to be in the same place. They both happen to be where y equals -2. Since I actually have a point at -2 and I have a hole at -2, the point overtakes the hole, and so it wins. And so I actually have a point at -2, so there really is going to be a point there. I can include it. So I put the less than or equal to sign, and I'm going to use a y this time because it's range. Range is y. And it goes all the way up to here where y equals +2, and there are 2 points there. There's one here and one here, and neither one of them is a whole, so it doesn't really matter, so it's included. So it goes all the way up to +2. So my range is all the numbers between -2 and +2. If I'm going to put it in interval notation, since both the -2 and the +2 are included, I put square brackets on both of them. So let's do a couple more examples. So now I have this pretty little graph right here. It looks like a smiley face, but on the ends it has these arrows. And if you will remember when you first learned how to graph and you first started graphing things, those arrows mean that that graph continues on forever and ever in both directions. It keeps going forever and ever and ever. This is a continuous graph because all the points are connected, which means we are not listing the ordered pairs. Now, when it has these little arrows on the ends, it is continuing on. And if you will look, this graph does not go straight up and it does not go straight out to the side. It is sort of going up and out at the same time. So it is going all up and to the left, and it is also going up and to the right forever and ever. And when that happens, what I get to say is that for my domain, my x values, I can't draw a line here because it doesn't have an endpoint. It doesn't end. It continues to the left forever and to the right forever. To the left forever happens to be -infinity. To the right forever happens to be +infinity. And so when I write it in set notation, this is how I include it. Now, infinity, believe it or not, no matter how much you want it to be, infinity is not a number, so you cannot include it. So you just have to put the less than symbols. It cannot be included. So it goes from -infinity to +infinity. Another way to say this is to put it in set notation. Now, since you cannot include them, my bad, interval notation. In interval notation, it looks like this. They have the parentheses instead of brackets. Now, if you don't want to write either one of those, because it includes every number from -infinity to +infinity, we can just say that it is all real numbers, so we can draw our fancy R. All three of these notations work. All three are acceptable. They all mean the same thing. It just depends on what you're most comfortable with. So now let's do the range. Now the range, there is actually a number down here at the bottom. It stops down here, and so I can draw a line across the bottom of my graph. However, because it has arrows, it extends on forever and ever in an upwards direction, which means it is going to go to infinity in the positive. But when we do range, we start at the bottom. So it starts at -2, and there is actually a point at -2, so we get to include it, so we put the or equal to symbol. But because of the arrows, it is going to go approach infinity, and so I have to do it this way. So if I'm going to write it in interval notation, the -2 is included, but my infinity cannot be because it's not really a number. Okay, so let's go do this other one. This happens to be a vertical line going straight up and down here, because that's going to be kind of important. This vertical line straight up and down, the first of all, it's continuous because, as you can see, it is connected. There are no gaps in it at all. Okay, it's not just individual points, so I am not going to write the ordered pairs. The domain here, please keep in mind, domain is how far left and how far right it goes. If you look at this line, it is going straight up and straight down. Therefore, it does not go left or right at all. So your domain is going to be the only x value this line ever touches, which happens to be right here, or right here, or right here, or even down here. It's the same x value no matter where you are on the line. X happens to equal on this line 1. So your domain for this is 1. That is it. And it is included because the graph actually passes through that point everywhere. So your domain is just 1. If you want to write it in interval notation, there you go. Or you can say X equals 1. All three of those work. The one you are probably going to see most often is the X equals 1. But that is your domain. Your range is how far up and how far down it goes. Because this graph has arrows on the top and on the bottom, means it extends forever in both directions. I can't draw my lines to show where it ends because it never ends. That means that this one goes from negative infinity to positive infinity. And so, whoops, squiggly bracket. And so if I write it in interval notation, it looks like this. And if I wanted to be real technical, I could just say it's all real numbers because it covers every number from negative infinity at the bottom to positive infinity at the top. So let's do one last one. We're going to do this horizontal line down here at the bottom. Again, it's continuous because everything's connected, so I will not write the ordered pairs. Domain is how far left and right it goes. This graph does not have arrows, which means it does have endpoints, and so I can label them. It goes all the way over to here on the left and all the way to here on the right. So when I write my domain, I start at the left, and the number over here on the left happens to be at -2. And at -2, I had a hole. It's an open circle. So -2 cannot be included, so I just put less than. And it goes all the way over here to 3, and at 3 I have a closed circle, so I can include the number 3. So my domain goes from -2 to +3. 3 is included, and so in interval notation, parentheses would go around the -2, but a square bracket would go around the 3. Now for my range, if you will remember, range is how far up and down it goes. Well, this line is horizontal. It doesn't go up or down. It only goes side to side. So my range is just going to be the y value that this graph passes through, which is right here at -6. So my range is -6. Or you could put it in interval notation, or you could just say that y equals -6. Again, like the other one, the one that is going to you see most often is going to be the y equals -6. So that is domain and range. Print off these notes, have them handy for yourself so that you can go look at them and have the pretty graphs. Otherwise, I hope you sketch really, really well, and we will practice this when you come to class tomorrow. I will see you then.